Howdy and good day, fellers. We are here in Algebra going over the homework from CO18 and CO19 and then getting into function notation. Probably new. Function notation in PO20. But first, back to CO18. Your homework was the back side of this page, or the second page, where you had to identify what type of relation we are talking about here, whether it's an XY table or a graphed segment, and then make the XY table or graph the segment based on the domain and the range. And like we talked about, when you've got your domain and your range listed like they are here, okay, you've got commas, it's specific numbers. The domain is 1, 0, 5, 6. The range is 4, 8, 12, 16. This is going to be an XY table or a function table. 1, 0, 5, 6 in the X column, 4, 8, 12, and 16 in the Y column, and that's it. Okay. With a segment, as we have in the one across from that, this tells us, using those compound inequalities, that X is between 2 and 4, and Y is between 1 and 5. So we're going to make our coordinate plane here. Okay, look at that. Very, very nice. And like we talked about, we can kind of math hack this by looking at the low end of the domain and the range and take that ordered pair. 2, 1. Plot it. Here's 2. Here's 1. 2, 1 is going to be right about there. And then take the high end of the domain and the range, 4, 5, and plot that. 4 on X is going to be right about there. 5 on Y is going to be way up there. So 4, 5, right there. So, and we connect those points to make our segment. Again, it's not a line, so we're not putting arrows on it. It does not go on forever. Okay, it starts at 2, 1, ends at 4, 5. And as we can see here, this is a segment with a domain between 2 and 4. Every X is between 2 and 4. And it has a range between 1 and 5. Every Y value is between 1 and 5. Okay, so that's what yours should look like. If you did the crisscross pattern instead, your segment might look like this. You don't need both, but either one is okay. Either one is okay. Next row, we start with a segment. I'm going to make my coordinate plane. The low end of each of these, -3, -4. So here's -3 on X. Here's about -4 on Y. And I'm going to make my first point there. And then the high end of the domain and the range, 4, 1. Let me write that, -3, -4, 4, 1. It's going to be right about, there's 4, 1, right about there. And we connect them, okay? And again, we see that our domain, which is X is between -3 and +4, that's where all of our X values are. They're between -3 and +4 on the X-axis. Our range, all of our Y's, between -4 and +1. We look at -4 and +1 on the Y-axis, and all of our Y values are in between there. Okay, if we kind of make an imaginary box around these points, nothing leaves that box, right? It goes from corner to corner. Of course, if you use a crisscross pattern, our other segment that you could make would go from here down here, okay? And that would work too, either red or green. The next one is an XY table. How exciting. The domain, -5, -2, 6, 10, 9. The range, 3, 4, -1, 8, 2. That's all there is to it. Thrilling stuff. The next row, we have our segment again. We know that because of compound inequalities, so I'm going to put my coordinate plane there. The low end, -5, 0, is going to be on the X-axis and -5, so there's my first point. The high end, 0, 4, is going to be on the Y-axis at Y equals 4, so there's my point, and here is my segment. So again, we see that on the X-axis, everything is contained, all of our X values are contained between -5 and 0. as the domain says. All of our y values are contained between 0 and 4, as the range said. And then if you made the other possible sign, I'll do blue this time so you can get multiple colors here. That's always fun. It looks like that. So either the green or the blue segment is acceptable. Both of those have x's that stay between -5 and 0, and y's that stay between 0 and 4. And this is why we don't put the arrows on them, right? It's not a line, okay? Everything's got to stay contained within this given domain and within that given range. If you put arrows on it, then you're saying it extends forever, and that every x value is included and every y is included, which it's not. It's got end points, a beginning and an end. And then the last one, we end with an XY table. Domain 10, 20, 30, 40. The range 40, 20, 30, 10. Okay. And there you got it. Give you a minute to absorb, jot anything down you might need. If you have any questions, comments, concerns, complaints, comments, congratulations, or criticisms on this, feel free to send me an email. I'll check it during the course of the day today and get back to you if you have any issues. Then we went on to CO19, where we learned about functions and had a lot of fun doing it. Pause for laughter. Okay. And your one question you needed to do was down here, the brain buster at the bottom. The ordered pairs of a function are 4, 3, -2, 1, 3, 6, and 0, -5. So the reason why it's a function is we look at those x values and they don't repeat, right? We talked last week about how a function is a relation where every input, x, has exactly one output, y, which basically means that x can't repeat itself. Okay? Y can, and then we got into that great example of the birthdays, how we said that it's okay for different people to be born on the same day, okay, but it's not okay for the same person to be born on different days. Despite your objections, that's just not how it works, okay? So it's a function right now because x does not repeat itself. So then the question is, what is an ordered pair that could be added to make the relation not a function? Basically, you needed to add an ordered pair that either started with a 4, with a -2, with a 3, or with a 0. It doesn't matter what the y is, okay? As long as it wasn't, 4, 3, because that ordered pair already exists here. And as long as this wasn't -2, 1, because that ordered pair, is already part of it. It's the same point. So as long as you made one of those x values repeat, it really didn't matter what y value you put with that repeated x. That's what makes it not a function. Okay? And again, anything with that, feel free to send me a note and I will respond to you. So now we move on to PO20, our first power objective of the unit here, on function notation. Function notation. And I don't know what experience you've had with this before. Usually I'm able to ask you. This time I am not. So I'm going to assume that it's brand new for everyone. But maybe you'll pick up things here and there along the way as we go. So function notation, it accomplishes two things for us. Number one, it identifies, that's kind of big space there, it identifies a relation as being a function. It identifies a relation as being a function. So if you look, and primarily with the equations here, if you look at an equation and you see it starts with either f of x or g of x or h of x, the three examples I have down below there, it's telling you that it's a function. It really doesn't have to be f, g, and h. It could be anything. But f, g, and h are probably the most three common variables that you'll see to determine function notation. But if it was d of x, that would be a function. Or if it was, p of r, that would be a function. Okay, it's really just a way to identify it as a function. Why so many variables? Why f, g, h, and then it could be other things too? Why not just, pick one thing? Just pick f for function, right? The reason why is because if you've got multiple equations graphed on the same coordinate plane, like if I were to graph all three of these equations on the coordinate plane, you know they're all functions because they're in function notation. They have that f of x, g of x, or h of x, but also they could be easily identified on the coordinate plane. These are not the actual graphs of these. I'm just going to kind of quickly make this up. But if I graph f of x here, I could label it f of x. If g of x looked like this, which it kind of does actually, then I could label that g of x. If h of x kind of did this thing, right, I could label that h of x, so that you could look at the graph, you could compare it with its equation, and not have to search for it, right? So it's kind of a labeling as well as identifying that a relation is a function. The second thing that function notation does is it, how do I write this? No, hold on. Oh boy. Ugh. I'm dropping erasers. I'm dropping markers. I bent over. My hat fell off. This is just quite a scene to behold here. No, the eraser's in the wrong spot. Oh my gosh. Number two. Yeah, I will start that. Tells us if we're solving for x or y in a given equation. Your experience with slope-intercept form before, y equals mx plus b, in every linear equation, which is one that when you graph it on the coordinate plane makes a straight line, you have an x and a y. They might not be the variables x and y specifically, okay, because variables can really be any letter that just plug in there. But when we talk about x, we're talking about kind of the x-axis variable, and y, we were talking about the y-axis variable there. So the second thing that function notation does is it tells us if we're solving for x or y to gain information about the equation or the situation. So what does that look like to tell us when we're solving for x or y? This is a key point, so this can go on a help sheet. The examples that we do here cannot go on a help sheet, but this statement can. When it says find f of 2 when f of x equals 5x minus 4, okay? In this, this f of x, if you kind of think of y equals mx plus b, if you haven't had slope-intercept form before, this is an equation that we'll get to shortly. But basically, what I want you to focus here, don't worry about the m and the b. Just look at that x and the y, okay? F of x is really another way to represent the y-axis, or your value for the y-axis. G of x, same thing. H of x, same thing. So when it says find f of 2, when f of x equals 5x minus 4, we've replaced this x with 2 right here. So they are giving you the value for x. Okay? In the equation f of x equals 5x minus 4, they're giving you what to plug in for x. So it means find f of x, which remember is just your kind of y-axis, when x equals 2. Okay? Find f of x, or find y, that value for the y-axis, when x equals 2. When it's written like this, another way to kind of explain this, and this is actually how I wanted to define it earlier but couldn't find the words, it's giving you the input. It's telling you what to input into the equation for x to get your value for y. So down here it says use f of x equals x squared minus 5 and g of x equals 12x plus 10 to find f of 4, f of -3, g of 6, g of 0, and g of -8. I said before that function notation is kind of used to label things. Which equation do you think I'm going to be plugging this 4 into? F of x or g of x? Well, f of 4 goes into f of x. Okay? And what this means is I want to find f of x when x equals 4. So I'm replacing the x variable in the equation with 4. I get 4 squared, which is 16, minus 5. F of x equals 11. Remember, this is just kind of a function notation way to write y. So the ordered pair that I've just found in this equation, I replaced x with 4. So there's my x-axis value. And I solved it for the y-axis value, or f of x. The ordered pair is 4, 11. Okay? So f of 4 is your value for x. F of x equals 11, right? That's our value for y, 4, 11. The next one, f of -3. Again, I'm going to that f equation, and I'm plugging in -3 for x. So f of x equals, and we've talked about this before, when you square a negative number, make sure you put it in parentheses, especially if you're using a calculator to help you. A -3 times a -3, that negative times a negative is a positive. And if you don't put parentheses around that in your calculator, it's only going to square the 3 and not the -3, and that does make a difference. So the -5 doesn't change here, but we have f of x equals -3 squared, which is positive 9, minus 5. We get f of x equals 4, so our ordered pair. -3 is what we plugged in for x. 4 is what we got for y. The ordered pair is -3, 4. Okay. G of 6, now we're switching to the G equation here, which is g of x equals 12 times 6. Just replace that x with 6 plus 10. G of x equals, 72. 12 times 6 is 72 plus 10. G of x equals 82. Okay. So the ordered pair, when x was 6, we plug that in and solve for g of x, which is really just the y-axis value, 82. So 682 is an ordered pair in 12x plus 10. G of 0. Okay. 12 times 0 plus 10. Again, we're being given the value for x, plug it in to solve for y. G of x equals 12 times 0, which is 0, plus 10. G of x equals 10. The ordered pair, x is 0, y is 10. And lastly here, g of -8. Still in the g of x equation, 12 times -8 plus 10. 12 times -8 is -96 plus 10. That gives us -86 as our value for y. So the ordered pair, when x was -8, that's what we plugged in. Our y value is -86. So really look at the relationship here, right? Because when it says g of 6, that's our x. That's what we plugged in for x. Okay, and the result that we got, that 82, was our y value here. And it goes back to that y equals mx plus b, which, again, if you haven't used that before, we will get there shortly, but that's where this kind of comes from here. But g of something or h of something or f of something, that gives you the x value to plug in. You'll know that when you're solving for x, because the other way that you'll see this says 4 f of x equals 2x plus 1. find x when f of x equals 9. Now remember, this f of x is really just a way to write y. Okay? So what this is really saying here is for y equals 2x plus 1, find x when y equals 9. Essentially, well, means find x when y, that f of x, equals 9. Okay? So in this case, let's write that down. Find x when y, the f of x, equals 9. So in this case, we are just replacing f of x with 9, and we're finding the x value that makes that happen. That gives us 9. Essentially solve for x here. Two-step equation. Subtract 1, divide by 2. I believe we get x to be 4. Okay? So when you're solving for x, it'll say find x, right? Find x when f of x, when the equation, when y equals 9. So down below, use f of x equals 6x plus 8 and g of x equals negative 10x plus 18 to find x when f of x equals 62. So in our original equation, which is f of x equals 6x plus 8, we're just going to replace that f of x with 62 and find the x value that makes that happen. So subtract 8 from both sides, opposite operations here. We get 54 equals 6x. Divided by 6, we get x equals 9. The ordered pair here is 9, 62. X equals 9, and y, or the function, equals 62. So 9, 62. Exactly the opposite as we did up above. Here we're being given the value of the equation, the value of the function, that y, and we're solving for x. The next one, find x when f of x equals 2. So we take our original f of x equation, we plug in 2. So this time 2 equals 6x plus 8. Subtract 8 from both sides. Negative 6 equals 6x. Divide by 6, and we get a value of negative 1 for x. So the ordered pair, x is negative 1, y is 2. The next one, find x when g of x is negative 62. So now we go to the g of x equation, and we're plugging in negative 62 for g of x. Subtract 18 from both sides, opposite operations. Divide by negative 10, and x equals 8. In order for the equation to equal negative 62, x needs to equal 8. So the ordered pair is 8, negative 62. G of x equals 18. We're replacing g of x with 18 in the equation now. So 18 equals negative 10x plus 18. We're finding x. Subtract 18 from both sides. 0 equals negative 10x. Divide both sides by negative 10 to get x by itself, and x equals 0. Our order pair is 0, 18. Right? So in all of these, just kind of, the value that we're given is the y value in our order pair, because that's what we're being given. We're finding x. Negative 1 equals x. Negative 1 in order pair. 8, 0. Look at the position of those. Okay. The last one, f of x equals 98. We actually go back to the f of x equation now. I switched it on you. Okay. So we replace f of x with 98. 98 equals 6x plus 8. Subtract 8 from both sides. 90 equals negative 6x. Divide both sides by negative 6. And we get negative 15. Why did I put a -6 there? I don't know what I was thinking. I think I was thinking about tacos or something. I'm kind of hungry. Positive 6x, that was, okay, which is positive 15. But that's why we check, right? After I wrote that -15, I went back and just kind of mentally plugged that in and thought, wait, that's not going to work. That doesn't give me 98 when x is 15. So everyone makes mistakes, and checking your work does matter. But anyway, we solved for x. X is 15. The y value is 98. That's what we were given. And there's your introduction to function notation. The second page of this for your homework. The first part here says answer each question below. What is the order pair being described? So it says, what is f of 4 when f of x equals 2x plus 12? Your first decision here is, what variable am I being given, right? What am I solving for? So when it's asked like this, what is f of 4 when f of x equals 2x plus 12? Kind of the hint here, you know, if it says find x, then you know that you're being given y, right? Because they're not going to have you find x if that's the variable that they're giving to you. That's pretty easy. So we're replacing x with 4. Okay, replacing x with 4. So you would set this up: f of x equals 2 times 4 plus 12, and then you're just solving that. Okay, 2 times 4 is 8, plus 12 is 20. So f of x equals 20. The ordered pair here says, write the ordered pair being described. X was 4, that's what we plugged in. The value of the function, what we got out of it, 20. Okay, x, y. What is g of 5? We're plugging that 5 in to both x's that we have here. Okay. What is g of -2? We're plugging that in for both x's that we have here. Right? And if it says find x, then they're giving you the y. F of x equals 16. We just replace f of x with 16, and we find x. We solve for x. Okay. Now, the context of function notation, you know, when are we actually going to use this stuff? Here are two examples. Okay. The first one says the function d of t. So remember earlier I said that, you know, f of x, g of x, h of x, the most common, but you might see, you know, p of r or something. Here we have d of t, where d represents the debt, right? D of t is the national debt in trillions of dollars, and t is the number of years since 1970. So this graph, even though it says 0 here, you know, 0, 0 down at the origin here, it's not year 0, okay? If t is the number of years since 1970, that 0 represents the year 1970, right? And then 5, t is 5, represents 1975. 10 would be 1980. 15 would be 1985. So Mr. Schultz was born right there, okay, 1984, right? But that's what this graph is saying. It's not 0 to 45 on the x-axis or the t-axis here. It's a number of years since 1970. And then the debt, the d of t, the y-axis here, is not dollars. It's trillions of dollars. So back in 1970, this ordered pair 02, I'll kind of write it up here, okay? 02, in context, what that means is in the year 1970, the debt was $2 trillion. Right? But because writing 1970 can get kind of bulky for the years there, and because of course 2 trillion is huge, okay, that's why it's labeled as, you know, the debt in trillions of dollars. But anyway, it says, what is d of 40? Write your answer in context. So first of all, what are you solving for here? Okay, t has been replaced with 40. So you're looking at the graph here. in saying, what is the value of the function when t is 40? I'll kind of circle this here. Number one, t is 40. The value of the function right there, that's about $10 trillion. So what is d of 40? 10 trillion. In context, this means that in 2010, right, 40 years from 1970 plus 40, 2010, the debt was $10 trillion. That's the context here. That's what that point tells us. Right? Then what is d of 25? Write your answer in context. And then find t, so find the year when the debt is 14 or 14 trillion, then write your answer in context. That's what that one is asking you to do there. Down below says the function f of x represents the height of a rocket where x is the time since the rocket was launched. So 0 right here is when it was launched, then 1 second after, 2 seconds after. I'm down here right now, sorry. Then 1 second later, 2 seconds later, 3 seconds later. So since the rocket was launched, that's what your x-axis is. And y is the height of the rocket in feet. Now it makes sense that this graph is like a parabolic shape here, right? The rocket goes up, goes up, goes up, loses steam, gravity kicks in, and back down Earth it goes. Okay. Number one, what is f of 7? Write your answer in context. Number two, find t when f of x is 300. Write your answer in context. What does that solution mean? And then number three, how high is the rocket at its highest point, and how long did it take to get there? So, function notation, there you have it. If it's new, welcome to the world of function notation. If this is review, then maybe you've seen it in a couple contexts where you haven't before, just brush up on it. But either way, PO20 is your homework for tomorrow. Email me, please, if you've got questions, comments, concerns, complaints, compliments, congratulations, or criticisms, and we will go over this in our next class. Have a great day, folks. That is how you math. Don't forget to like and subscribe.